All right, so in this video we are going to talk about how to find the inverse of a function algebraically. There's a few steps. Step one, if the problem is written with f of x, you need to change it from f of x equals to y equals. So no math there, just something you need to do. Step two, we're going to swap out the x and y. With each other. And this goes back to what we talked about when we graphed. Inverse functions have xy's that are reversed. So that's essentially why that's happening here. Step three, now you need to solve for y, which is now in a different place after step two. And then finally, step four, rewrite with the inverse symbol instead of y. So really only steps 2 and 3 are we doing any kind of math. And really you could even make a case step 3 is the only true math step here. Let's get those steps written down and we're going to work out 4 examples. So these say determine, remember this is the symbol for inverse. So it wants us to determine the inverse for each function. And then it says to check each answer using composition of functions. Remember, composition of functions, when we do a composition of functions, our answer should end up being x. So I'm going to do that as well. All right, so step one on number one is rewrite it as y equals instead of f of x equals. And then step two, since inverses have xy's that are reversed, we're going to reverse the x and the y. And then finally, step three, we're simply going to solve this for y. So add 7 and divide by 2. So we get x plus 7 divided by 2, or you'll see this written as 1/2 x plus 7 over 2, or 1/2 x plus 3.5. But we also want to go ahead and slip the inverse symbol in there. We're going to check our answers in the last step after I do all 4. But for now, let's just work on finding the inverse. So this should be the answer, either one of these. All right, number 2. I would encourage you to try to pause the video and try to do this on your own. Swap out the x and the y, and then solve that for y. To solve this one for y from here, we want to undo that divide by 4. Divide by 5, so we're going to multiply both sides by 5. So we get 5x equals negative y plus 11. Subtract 11 from both sides, divide everything by negative 1. So negative 5x plus 11 that should be our inverse. All right, I'll do one more and then have you try number 4. And then we'll check these. So y equals 1/2 x minus 5. Swap out the x and the y. and then solve for y. Remember, the easiest way to get rid of a fraction multiplier is multiply by the reciprocal. So this is one a lot of people end up missing, because we're multiplying both sides by 2. It's going to cancel out that fraction. But you have to remember there are already 2 terms on the left-hand side. So you have to distribute the 2 to the 2x to the x plus 5. So our answer is 2x plus 10. I encourage you to pause the video and try number 4. And remember, at some point to get rid of that 3/4, you're going to have to multiply by the reciprocal. So I've gotten to this point. And then to finish it off, we're going to multiply both sides by 4/3. Remembering to distribute it to that binomial. So our answer is 4/3 x minus 16. All right, so that's how you find the inverse. Checking it is optional. So I'm just going to check one of these. Let's check number 4. This is one we just did. Mark out number 5 here. Let's just try number 4. So again, if these are inverses, what we're doing is we're testing to see if the original function and this inverse function are actually inverses. And this is a good way to see if you've done the problem correctly, if you've made a little mistake in the problem along the way. So f of f inverse, let's do that first. So this means we're going to substitute x into the inverse function first. And that, of course, gives us 4/3 x minus 16. And then we're going to take this binomial and plug it in for the f function. So this is going to be 3/4 times something plus 12, and that something is the other function. 3/4 times 4/3, those are reciprocals, so we know those are just going to become 1x. 3/4 of negative 16 is negative 12, and negative 12 plus 12, of course, is 0. So that's x. But a true test is you've got to check it now the other way. So now you got to do f of inverse of f of x. So f of x is 3/4 x plus 12. And we're going to take that binomial and substitute it into the inverse function. Sometimes all of this notation can look confusing, but ultimately all we're doing is taking one function and substituting it in for the other. So instead of 4/3 x minus 16, like a lot of these steps, you'll get to the point where you can just skip them and just go straight to plugging one function in for the other. Then we can check it. 4/3 times 3/4 is 1 still. 4/3 times 12 is positive 16. And we end up with x. And again, that is just to check to see if those were inverses.